All right, let's continue the spatial resolution talk. So the ability of the system to record adjacent small structures. When I think of spatial resolution, I think of detail. So we talked about the geometric factors. Let's talk about the digital ones. Matrix size, pixel size, field of view, flat panel detector uses DELs, PSP plate size, and that's in CR, and some sampling frequency. Matrix size and spatial resolution. So the matrix is determined by the number of columns and rows in the image matrix. And we know that a large image matrix is going to increase spatial resolution because when the matrix size increases, the size of the pixel decreases. Smaller pixel, more detail. I always tell my students, I think of my husband, and he would love the biggest big screen TV for watching football. The smallest pixel, so you can see those individual blades of grass. Or if you think of your radiologist sitting in front of this screen, they love those big screens, those big monitors, right? So you always want a large matrix size. What if they give you some examples of sizes? So go with the biggest numbers. The biggest numbers of the rows and columns are going to give you the biggest matrix. So we want big matrix. Pixel size. So pixel is your picture element. It's determined by the matrix size and the field of view. As you remember, increase matrix size, decrease pixel size, and that's what we want. Ideally, the pixels are kept small, and that's what we would like to have. So small pixels are going to increase your spatial resolution. Some terms to keep in mind are pixel pitch and pixel density. So pixel pitch is the size of the pixel measured from center to center. So the center of one pixel measured to the center of the other. I just think the pitchers in baseball pitch from center field, or from the pitcher's mound is in the middle. I know, it's not center field. Don't tell my husband I don't know my baseball, but that's how I remember it. And then density is the number of pixels sort of in the area of millimeters, okay? Field of view. Field of view, we talk about field of view as the size of your light field or how open or wide it is. Ideally, we want a smaller field of view. Smaller field of view gives us better spatial resolution, right? So we should always be collimating in. Watch the terms. Increasing field of view means opening your field, making a bigger light. Increasing collimation, smaller light. Watch those terms, okay? Field of view, collimation, don't mix them up. Your flat panel detector is the advancement in C-arm imaging, right? So your older C-arms have this big image intensifier, this big cone. The new ones, the flat panel detector, is essentially that indirect DR plate, right? So the indirect DR plate has a layer that's the TFT. And if you remember from your indirect DR, the TFT is filled with DELs. So if it's talking about flat panel detector element size, those are your DELs. You always want small DELs. Put DELs and pixels together, you want them to be small. The smaller they are, the more information, higher spatial resolution. PSP. When you see PSP plate, I want your brain to say they're talking CR. Remember that photostimulable phosphor that's in that phosphor layer that holds the latent image? The red laser comes along and activates it. So PSP plate size is talking about CR plate size. And I know a lot of you have not worked with CR plates. So CR plates, we had to use a specific size for each part. And I know with digital world, we have the one size plate. But ideally, you chose the smallest plate size possible. And so it was an 8 by 10, a 10 by 12, 11 by 14, 14, 17, any of those above. So you chose the smallest plate size appropriate for your part. Why? Because the CR plate has to process the whole plate. So if you used a 14-17 for a hand and only exposed this one little area, then it has to process the whole plate, right? So a decreased PSP plate size increases your resolution and detail. It gives you better detail. So CR plate, PSP plate, you want the smallest one possible. Sampling frequency. So sampling frequency, if we go back to that CR plate, remember that imaging plate goes in the reader. It has a red laser. It moves in a raster pattern, left to right, down the plate. as it's going in that raster pattern, it is sampling those phosphors. So ideally, you want a faster sampling frequency, smaller pixel pitch. The more pixels that it samples, the better spatial resolution. So you want a high sampling frequency to increase your resolution. The Nyquist frequency is a term that sometimes students ask me about. It comes up here and there. It's the relationship between the sampling frequency, which is the number of pixels per millimeter scanned by your laser, and the spatial resolution. So how many cycles per pixel and size of pixels is being scanned. Spatial frequency and measuring resolution. So your spatial resolution is measured in line pairs per millimeter. More line pairs per millimeter, better the resolution. There's a minimum of 2.5 line pairs per millimeter. Sorry again, I can't really talk today. For diagnostic image quality. So that is the minimum. Ideally, we want more. So with each advancement, we get better spatial resolution. Right, so CR, then improved to DR, and we're improved. But the spatial resolution is also determined or limited to the size of the pixel for DR. Your MTF, or your modular transfer function, is the ability of a system to record available spatial frequencies. It is your best measurement of spatial resolution. It's going to give you a ratio of how accurate the object is produced. A perfect imaging system, which is not going to happen, but in your ideal world, your MTF will be a 1, and so that would be 100%. DR has the highest MTF. It's controlled, by your pixels, your spatial resolution. This is an example. So this was an MTF of, say, 0.8, and that was 80%. So ideal MTF is going to be 1, which is equal to 100%. And so those are your digital factors that control your spatial resolution. I want you to know, why do they affect each other and which way do they go? If I increase this, where does spatial resolution go? Does it increase or decrease? If you can explain that and answer that in a sentence, then you know your imaging chart and you can pass your ART.